Okay. Good evening, everyone. Or good day, everyone. I don't know the location you are coming from or you connected from, and I don't know the time of your day. So you are welcome to this lecture. The lecture is titled Design and Simulation of Electronic System using Implementation of 5-volt DC Power Supply for Microcontroller Applications as a case study. This lecture is brought to you by Mechatronics team, Embedded System Team Mechatronics Department, Federal University of Technology, Owerri. Let's go through the outline. This lecture is going to take place in 3 modules. In module 1, we are going to introduce the team, and then there will be a brief introduction to electronic engineering. In module 2, we're going to look at load requirements for analysis of 5-volt DC power supply. We look at component selection before we get into operational principle of selected components. The power supply will be modeled, and then there will be tutorial section to end module 2. And then in module 3, which is the final module, the power supply design will be simulated. The components will be connected together on a breadboard before mounting it on a Vero board, after which the system will be tested and the results validated. So we welcome you. Please stay connected and listen to the lecture all through. The lecture will be separated. The videos will be separated. Module 1 will be on a separate video. Module 2 will be on a separate video. And then module 3, which is the continuation of the lecture, will be on a separate video. The idea is to break them into modules so that it will be easier for our readers to follow. This is Embedded System Team Photo. I am Engineer Dr. Ekene Samuel Mbon. So I will hand over the control. I will hand over the other introduction to Mr. Okechukwu Gospel to introduce the rest members of the team. So, Gospel, over to you now. Unmute yourself and introduce other members of the team.
Good day, everyone. My name is Mr. Okechukwu Gospel Chibikem, and we have Mr. Obi Prince Chukwuemeka, Mr. Obasi Kelechi Justice, Mr. Barry Up Daniel, Mr. Lucky Ifeanyi Chidera, Mr. Nwankeze Chibuike Peter, and Ms. Anyanwu Faith Chinaza.
Okay, thank you so much. This is 8-man team. 8-man team, and in the team is a lady, but it's 8-man team. So we continue. Thank you, Gospel, for that introduction. So let's go over to business. Who we are. We've already said we are Mechatronics Engineering Department. We are from Mechatronics Engineering. We are from Mechatronics Engineering Department, Federal University of Technology, Owerri, Nigeria. What do we do? We are engaged in capacity building embedded system development, as you can see from and by these pictures. These are the section, one of the sessions we had in the past, where we developed capacity among ourselves. Let's play the video. Who was talking on who was talking on that video? Who was talking on that video?
It was Chibike.
Eh?
Chibike. It was Chibike. Chibike.
Okay, Chibike. Sorry. Okay. Okay, that's one of the sections we had with mechatronics engineering students, their 100 level. That was one of the sections we had with them when we trained them on automatic street rail system. This picture are part of one of the snapshots we took while during that training. So we engage in training, and then we also supply quality case, instrument, and other electronic components. You can just contact us. Just contact us on the comment section. We will get back to you. And then we supply components, meters. Just contact us. We will get back to you. We sell at a very good price. And then what's our core value? Excellence, 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 excellence in project. Excellent. Excellence. Excellence. Chibike, that's a spelling of excellence, right?
Yes, sir.
Yes, sir.
Excellence in project delivery. Okay. So we continue. The picture before us is 3-mode automatic changeover system. This is one of the final year project of our final year students. That was in 2025. This is proof of concept. Now, what is electronics? We want to design power supply for an electronic system. It's important we have a good understanding of what electronics is all about. What is electronics? Electronics can be defined as a branch of physics and engineering that deals with the study of electron behavior, flow, and control under different conditions. Such conditions include vacuums, gases, of semiconductor materials where electrons are observed. So when we talk about electronics, we're actually talking about controlling the flow of electrons in vacuums or gases or semiconductor materials. That's what electronics is all about. It's a branch of science and engineering that deals with the study, design, and application of devices and systems that control the flow of electrons, what is normally called electric charge. So that's what electronics principally is. We are controlling the flow of electrons. It started with vacuum tubes. Many of us may not be familiar with vacuum tubes that was available in those days in black and white televisions. And you go to radio stations in those days, you see them. When transistors, BJ transistors, the bipolar junction transistors came out, they replaced vacuum tubes. And now we are dealing with semiconductors today. We are dealing with MOSFETs, diodes, and all those stuffs. We are dealing with control of electrons through them. You are hearing me because of these components. For example, we are transmitting information now through the air. Air is a gas. Without the air, telecommunication wouldn't be possible. And it's actually the control of information. It's not everybody that is in this meeting. It's a controlled information. So it's about how we use electricity to process information, control systems, and perform useful tasks using components like circuits and devices. Electronics is a scientific and engineering discipline that studies and applies the principles of physics to design, create, and operate devices that manipulate electronics and other electrically charged particles. The key word is control of electrons. Electronic engineering is a subdiscipline of electrical engineering that emerged in the early 20th century and is distinguished by the additional use of active components such as semiconductor devices to amplify and control electric current flow. It's a branch of engineering that designs, develops, and tests electronic circuits, devices, and systems using components like transistors, diodes, and integrated circuits, that is IC. It focuses on low voltage applications involving signal processing, telecommunications, computer hardware, to create technologies like phones, computers, robots, etc., etc. Key aspects of electronic engineering, design and development. You see it in consumer electronics, medical devices, navigation systems. So, specialized subfields include telecommunication, signal processing, control system, and microelectronics. As you progress in engineering field, you begin to encounter these things. It often overlaps with computer engineering and software to bridge hardware and software, ensuring efficient functionality. Actually, this is where embedded system comes in. As we progress, you will discover that there are four basic types of electronic components. The four basic types of electronic components includes the four basic types are capacitors, resistors, diodes, and transistors. So if anyone is going to master electronics, that person must be grounded in these areas. It's like you want to master a language, you have to be grounded in the alphabet, the consonants of that language. So Capacitor, resistor, diodes, transistors. Permit me to tell you that these are the fundamentals of electronics. Somebody has to get to the level of understanding the basic working principles of these components if you are going to do well in electronic design. Is there any question so far? Please feel free to ask question. Are we together?
Yes, sir.
Yes, sir. Yes.
Okay. Can I proceed?
Yes, sir.
Yes, sir.
Yes, sir,
Okay.
you can.
Now, what actually is the difference between electronic engineering and electrical engineering? To confirm that you can see hear me clearly, somebody should read what is on the screen. Maybe Prince, read what is on the screen. Prince, you are muted. You are muted. Unmute yourself and read.
While sometimes used interchangeably, electronic engineering is a subcategory of electrical engineering. Electronic engineering focuses on small-scale components, low voltage, and information processing. Electrical engineering deals with large-scale applications like power generation, transmission, distribution, and electrical machinery. Thank you.
Okay, that's good. So you can actually practice electronics within the confine of your room. But if it is electrical, imagine 11 kVA transformer. You can't deal with that in your room. So electrical engineering basically deal with generation of power, transmission of power, distribution of power, and other electrical machinery. Electronics deal with small scale components, low voltage, information processing. When we talk about Internet of Things, in fact, Internet, essentially, the backbone is electronics. Okay? Importance of electronics, we can't overemphasize this. Electronics are the backbone of modern technology, driving innovation in communication, healthcare, industrial automation, and daily efficiency through components like transistors and integrated circuits. We said that before. They enable critical technologies such as computers, smartphones, artificial intelligence, and advanced diagnostics, significantly improving efficiency, safety, and connectivity. Everywhere you go, you see electronics. You enter your vehicle, electronics. Your body of light, electronics. It's electronics, electronics, electronics. I can't imagine the world without electronics. We've already made mention of application of electronics. You see them in communication systems, healthcare and medical technology, industrial automation and robotics, consumer electronics and home automation, energy and sustainability, and automotive technologies. Is electronics all the way. Key enabling technologies that drive electronics: 1, semiconductors and ICs. These are the core components of modern computing. Artificial intelligence. Electronic components power computer graphics and machine learning algorithms. Nanotechnologies, used for designing, manufacturing, testing, and allowing for smaller and faster circuits. So here we are. We want to make mention of some basic components of electronics. Please, what is this?
That's a diode.
What is this?
Capacitor.
That's a capacitor.
This one? This one is an inductor. This one is an inductor. What is this one?
Resistor.
A resistor.
A resistor. If you're having noise at your background, please unmute yourself. This one is a transistor. What is this one? MOSFET. This is an optocoupler. This is a triac. This is a relay. We can classify these components into active and passive components. So if your background is not noisy, just mention your name and read what is on the screen. I want to be sure we are together.
Good day, everyone. My name is Obasikelechi Justice. Active components require external power to operate and can amplify or control electric signal, e.g., transistor and diodes, whereas passive components cannot generate energy or amplify signals, often acting as consumer, storers, or filters, example, resistor, capacitor. Active components add power gain, while passive components always have a gain less than 1.
Okay, so active components have a way of amplifying the signal, modifying the signal. For example, you can use transistor to amplify a signal. But passive components, they do not do that. They can, something like resistor is not a passive, is not an active component. And so almost every time the gain is less than 1. Gain is output over input. So the output is always less than the input. That's why the gain is always less than 1. Key differences. Power uses. Active components need an external power source to function. Passive components do not need external power to operate. For example, an integrated circuit IC, if you want to use an integrated circuit, you must power it. If you connect everything around integrated circuits and you don't power the IC, you are just wasting your time. Or you use an operational amplifier, at the end of the day, you don't power it. It's not going to work. Your circuit can be correct, but without power, it won't work. But stuff like resistor, capacitor, you don't need to power them. Just connect them. When the circuit comes on, it begins to work. Signal amplification. Active devices can amplify signals, increase power. Passive devices cannot. Energy generation. Active devices can generate and inject energy as voltage or current. Passive devices only store or dissipate energy. Control. Active components can control the flow of electricity. Passive components just restrict or store them. Is it clear to you now? The difference between active and passive components, is it clear to you, or you have any question or questions?
It is clear, sir.
It's
Okay,
clear, sir.
so we continue. Examples of active components. Another person read what is on the screen.
So we have examples of active components.
Tell
We
us
have
your name.
transit. Okay, my name is Bayob Daniel.
Okay, go ahead.
So examples of active components, we have transistors, BJTs and FETs transistors. We have integrated circuits, ICs, diodes. Examples of passive components, we have resistors, capacitors, inductors, and transformers.
Okay,
Active components like
go
are
ahead.
necessary for signal processing, while passive components like resistors are critical for signal management and power distribution. Thank you.
Okay. So that is the end of Module 1. Please subscribe to our channel today, like and share the video, answer the tutorial questions on the comment section. There is a tutorial question here. What is the difference between active and passive components in electronics? List 3 examples of active components. List 3 examples of passive components. Tell us the location where you watch the lecture. Tell us the location from where you watch the lecture. Then the last one, FUTO is an acronym for dash. We want to say a big thank you for creating time to listen to and watch our lecture. So we hope to welcome you on Module 2, load requirement analysis for 5-volt DC power supply. Now we have introduced electronics, what electronics is. So we take a break. When we come back, we will begin the lecture on Module 2. So I stop sharing my screen